Hi guys, so today we're going to talk about polar coordinates and polar graphs and all that sort of thing. So make sure you turn to the part in your notes that says, let me see what it says on the first page. Let's see, polar coordinate system. So up until now, you've graphed on a rectangular plane, meaning there's an x-axis and a y-axis. So we're now going to look at another system called the polar coordinate system. This can be helpful if you're talking about navigation of things or directions or anything like that. So fix a point O called the pole or the origin. That's exactly what you would think of, exactly in the middle. From O, construct an initial ray called the polar axis. And we can see that in our picture right here. Each point P is assigned polar coordinates. R is the directed distance, think of that as the radius, and theta being the angle measure. Theta is counterclockwise when formed by the polar axis in OP. When theta is negative, we graph the point clockwise. So just like you would think of if I gave you pi over 4 and I told you to find pi over 4, you would go counterclockwise. If I gave you negative pi over 4, you would go clockwise. So graphing polar coordinates, unfortunately, this graph looks really, really bad and you can't really see it very well. So what I want you to do is turn in your packet to this page right here that says this is a 2-page document, and we're actually going to graph them right here. Okay, so let's start with A. Let's do 3 of them. So A is 3 2 pi over 3. So the biggest thing with polar coordinates is this part first will give you the angle. So 2 pi over 3. What you want to think about is you're looking at 2 pi over 3 and you're taking 3 steps towards that angle. So if I'm starting, I'm always starting at the pole. And notice my scale here. So like this is 1, this is 2, this is 3. So I'm going to take 3 steps towards 2 pi over 3. And that is right there. Okay. Facing at 2 pi over 3, take 3 steps forward. And again, just note the scale there. Okay, let's actually do number 4 because I want to do a negative angle. So negative pi over 3. Now, if you can't visualize your negative angles, remember you can always find a coterminal angle by adding 6 pi over 3, okay, or 2 pi. So that gives me 5 pi over 3. So another way to think about this, just like number 1, okay, is look at 5 pi over 3. So I'm facing towards this angle here, and I'm going to take 2 steps towards that angle. So 1, 2. That is point, what letter is that? D. All right. All right, let's do one more. Okay, let's do number 5. Okay, so first I look at the angle. It says negative 5 pi over 3. I'm going to find a coterminal angle because I'm more comfortable with that. So negative 1 pi over 3. So I'm facing towards pi over 3 right now. I'm starting at my pole or at my origin, and I'm facing towards pi over 3. But this one says negative 1. So instead of taking 1 step towards pi over 3, I'm going to take 1 step backwards. So again, I'm facing this angle right here. If it helps you to visualize, you can draw a line on it. But then I'm going to take 1 step backwards. And this right here is going to be point E. So again, if it's just positive, pretty easy there. If the angle is negative, you can either think about going backwards or clockwise or finding your coterminal angle. And then if your R value is negative, instead of walking that many steps towards your angle, you're going to walk backwards. Now, we'll talk about in class that this point right here can actually be named in a number of different ways. And we'll actually talk about that in a second too, because I could also say I'm taking 1 positive step towards 4 pi over 3. Those are saying the exact same thing. Okay. All right, so let's practice with that. Go back in your notes to where we left off, where it says naming polar coordinates. So if we have the point r comma theta, we can also represent that as r theta plus 2 pi k, meaning I add 2 pi, they use n right here. I'm going to change that to k because that's what we've been using. where I add 2 pi a number of times or I subtract 2 pi a number of times. Now, you could also say, represent this as a negative r, thinking you're directly across the circle, theta plus pi k. Okay, and we're going to look at this in a second. Let's do a couple examples, and hopefully this will make more sense. So first thing I'm going to do is just kind of visualize where I'm looking at. So I'm going to draw in 2 circles. So I am looking at 5 pi over 3, which is down here, and I'm taking 2 steps towards 5 pi over 3. So that's going to be where you are on your circle. So let's think about, first of all, is there another way I could say that with a positive r value of 2? Well, I know I can take this angle, and to get to the same spot, I could subtract 2 pi. So this is the same thing as saying 2 negative pi over 3, because negative pi over 3 and 5 pi over 3 are the exact same angle. So then the question becomes, what about if I were directly across from this angle? Okay, first we have to know what angle is directly across from 5 pi over 3. That would be 2 pi over 3. So I know I have a choice of walking towards an angle or away from an angle. Okay, so if I'm facing towards 2 pi over 3, which is exactly across the circle, so I'm facing this way, instead of walking 2 steps towards 2 pi over 3, I'm going to walk 2 steps backwards. Because those are on the same line, you're going to end up at the same place. 2 steps backwards, if I'm facing 2 pi over 3, will get me to 5 pi over 3. Now, the next question is there another way I could name this angle right here? Yes, I can find a coterminal angle. So minus 6 pi over 3 gives me negative 2, negative 4 pi over 3. All of those say the exact same thing and all label this point right here. Let's do another example. All right, let's do number 8. So negative 5, negative 7 pi over 4. So naturally, I'm going to want to find a coterminal angle because this one is negative. So plus 8 pi over 4 gives me negative 5 pi over 4. Anytime you're adding 2 pi, that's going to be the exact same angle. So 1, 2, 3, 4, 5. Now, towards pi over 4, we know that's right here, but this one says take 5 steps backwards. So the point I'm actually talking about is right here on my circle. Facing pi over 4 and negative 7 pi over 4 are the same angle, but take 5 steps backwards. 1, 2, 3, 4, and 5. That's the point I want. Well, how else could I name this point? I could also say take 5 steps towards this angle I highlighted in yellow. What angle is that on my circle? That angle is 5 pi over 4. Now, is there another way that I could name 5 pi over 4? Well, if I subtract 2 pi, I get negative 3 pi over 4. Again, these two angles are the same. That's why they have the same r value. And then these two angles are coterminal. That's why they have the same r value. So I highly recommend on these that you sketch a picture. All right, next section is going to be on polar graphs, okay? So we're just going to do the first 4 right here, which are pretty simple, okay? R equals 2 means a circle with a radius of 2. So just be careful with your scale, but that's going to look like this. All right, r equals negative 4.5 is still a circle with a radius of 4.5. The only thing that changes, and you're not going to be able to see this on your picture, but instead of drawing your angle counterclockwise, you would technically draw not your angle, but your circle clockwise. Again, that's not going to affect what it looks like on your graph, but it just changes the direction that it's plotted. Okay. All right. Next, theta equals pi over 3. So that's an angle. So that's just going to be this line right here at pi over 3. but we want to be careful. R could technically be negative, so I could also be going backwards, so it's this whole line here. All right, finally, number 4, I'm going to go ahead and find that coterminal angle. And negative 7 pi over 6 plus 12 pi over 6 is 5 pi over 6. But again, remember, R can be negative. So I'm going to travel all the way towards 11 pi over 6. All right, so for this next section, we have R equals 2 sine of theta, okay? So we're going to go through all of this right now with the points, okay? And then once you get the hang of it, you won't have to do it every time because you'll know the pattern. So remember, we're finding sine of 0, sine of pi over 6, and then multiplying it by 2. These are our theta values. So first, 2 sine of 0. Sine of 0 is 0. 0 times 2 is 0. Sine of pi over 6. Sine of pi over 6 is 1/2 times 2 is 1. Okay, again, this is just using your unit circle. All right, sine of pi over 3 is square root of 3 over 2 times 2 is square root of 3. All right, sine of pi over 2 is 1 multiplied by 2 because I have 2 sine of theta gives me 2. This one right here, we're still positive because we're in the second quadrant. So this is going to be square root of 3. And then 5 pi over 6, the sine at 5 pi over 6 is 1/2, but times 2 gives me 1. All right, at pi, the sine of pi is 0. 0 times 2 is 0. 7 pi over 6 is down here. Negative square root 3 over 2, negative 1/2. The sine is negative 1/2 times 2 is negative 1. 4 pi over 3. Negative square root 3. You should start to see a pattern here. Negative 1 times 2 is negative 2. Negative square root 3 and negative 1. All right, so let's plot these points. So we have 0, 0, pi over 6, 1. So that means take one step towards pi over 6. I'm not going to worry about pi over 3 right now just because that's a decimal. I'm going to graph the easy ones first. Pi over 2, take 2 steps towards pi over 2. Okay. 5 pi over 6, take one step towards that. Okay. All right. Then at pi, we're at 0. So 0 steps towards pi. That's just going to be at the pole or the origin. Then this is where it gets interesting. 7 pi over 6, so I'm facing this way, but I'm taking one step backwards. Notice that puts me at one step towards pi over 6, and I already have that point plotted. All right, 3 pi over 2, so facing this way, but taking 2 steps backwards, that gets me another point that I've already plotted at 2 pi over 2. And again, 11 pi over 6, looking towards 11 pi over 6, but taking one step backwards, that's going to get us that point there. So this is what your graph should look like. Think about why it looks this way. So because there's a 2, that gives me the maximum point that's going to exist, okay? Also, because it's sine, that means it's going to happen on your y-axis, okay? So you could go through and do each of these if you wanted to by plotting all the points, but I'm going to show you kind of what each of these will look like. This is cosine, really one cosine of theta. So that means it's going to be on the x-axis. Because it's positive, it's going to go to the right. So it's going to look something like this. Negative 3 sine of theta will be on the y-axis because sine is y. Instead of extending up to 3, though, it's going to go down to 3. And I should probably sketch a few more points, but that's essentially all that I'm going to require you to do is know the general shape of these graphs. All right, for cosine theta means it's going to be on the x-axis. It's positive, so it's going to be going right. And it'll look something like this, extending out to 4. All right, finally we have cosecant. Now, cosecant is a little bit different, and this one will require some making a table and going back to what we did before. So I'm going to pause right there with the simple ones, and we'll do the cosecants and secants together in class. You have this for practice. You're not responsible for the distance between polar points. If you want to, you can go ahead and graph some of these easier ones as well, and then we'll pick up with that in class. So that's kind of an introduction to polar. Again, we've plotted XY before, but now we're plotting R theta, where theta is the angle and R is the radius, or how many steps you're going either towards or away from that angle. Thank you.